Hello everyone. Today we got ourselves a really good problem from the 2022 January contest, and also this contest itself is just pretty good, I would say, because if you look at the silver of the same contest, there are also really good problems. Anyways, today we're looking at the drought, which is the first one of the gold contest. Pretty straightforward. You have an array, and each time you can decrease it by you can decrease any adjacent uh, elements of this array by exactly one, and you try to make all of them the same value by doing a certain number of these operations. However, you don't actually know the array. You only know the upper bound of each element in this array. And now you're trying to find how many possible arrays are there for which it is possible to achieve the goal of making every element the same just by decreasing adjacent elements by one each move. And n is surprisingly small, only 100. The upper bound is only 1000. So yeah, very small. Okay, so just looking at how I solved this problem last January just makes me feel so bad because I was so ors. I was such an orzosity back then. I was able to get through almost this entire problem with just a tiny DP transition trick that I missed and had to be reminded of by the solution. But anyways, yeah. First of all, notice that even though this seems very clueless because you're not only trying to find something by like decreasing every adjacent pair is already confusing enough, and now you're trying to find how many possible n tuples, that just does not sound humanly possible. However, notice that decreasing every two adjacent can also be translated into, okay, not translated, but like you can simplify a lot by just thinking about in what cases is this actually possible. Even though it's clueless in the middle, if you look at the endpoint, however, an endpoint can only be decreased with the single element next to it. So after you make the endpoint 0 or x or whatever that you want to make it, now the new element becomes the endpoint, and then you can just keep doing that on and on. So using this endpoint trick, you actually simplify this problem by a whole lot because now, okay, we can just look at my the formulas right here. So basically, we end up having, so say we have h1 and we have to decrease h1 and h2 just like I said because h1 is an endpoint, and first we assume we want to get all of them to 0. So now we have h2 minus h1 left, and that is an endpoint now because h1 is gone. And now I have to decrease h3 by h2 minus h1, turning h3 into this and turning that into an endpoint. So basically the sum of this whole thing is, the not a sum, but like the final term of this whole equation is going to be hn minus hn minus 1 minus hn minus 2, and then until we get to here. And notice how that cancels out because the last one must become 0. And if we open the parentheses with the sign of h1 being determined by a party of n, we notice that it's just 0 in any case if n is even. You can test this yourself because if n is even, the first one is h1 is positive, and then all cancels out. It's just really all the x cancels out, and the equation is equal to 0. However, when n is odd, the equation should be equal to x. Okay, now that we discussed something that seemed like not as important, it is actually very important because now we have to somehow figure out a number of equations like this that satisfy. It looked like a knapsack to me back then because I was so ors, because like literally knapsack is not that far away from what it actually was, but it doesn't look like a knapsack to me anymore now because I'm not as ors as I was last year. Anyways, we do a DP, very straightforward. And transitioning is straightforward. However, because we have to enumerate the x for the cases in which n are odd, we have to decrease the transition complexity by 1 by OH. And to do that, we use a prefix sum trick. And yeah, that is it. The implementation is actually quite simple for a gold problem, but I mean, it's DP, and I suck at that now. Anyways, we do a prefix sum with G, we enumerate the x, and we just decrease hi by x each time. So we basically treat x as 0 now. So everything is simpler, our lives are easier. And then we do DP transition. We enumerate how much is left from last time. However, we don't actually enumerate because we made a prefix sum array this time. So we don't have to enumerate, and we save that time complexity for enumerating the x instead. And then we output, don't forget, Oh yeah, don't forget to add x back at the end of each time we enumerate x, and also the answer is different for odd and even. So yeah, that is how we solve this problem, the drought from 2022 January, and it's a really good gold problem, and it just shows how much I fell off in the course of this year. And yeah, anyways, thanks for watching. See you tomorrow. Okay, so for the grind report today, I once again I'm a failure. I grinded for 3 hours and I solved one problem, and the coding is literally not even that hard. It's from I mean it's progress because I finally solved the last problem from 2025 US Open, and now I can officially claim that every single contest I've ever done, I can solve all of the problems on it. But it's really easy implementation, and the idea I like it just makes me feel so bad because I could have solved this last contest. Like during the contest itself, I probably could have solved it if I was just a tiny bit smarter, but I wasn't. So I just let platinum slip away. Anyways, yeah, and also just doing this problem review also makes me realize how much I fell off. Like this is actually a good problem, and the fact that I was able to get through basically all of this, I feel like now I have to grind math. Even though this might seem unrelated to you, here's the thing. If I fell off by this much over the course of 1 year for coding, I will fall off by the same amount over the course of 1 year for math. So if I don't keep reviewing math in the gap of my two grinds, this same thing that happened on coding is going to happen again for math, in which I fall off by an amount that I can't make up for in a short period of time. So yeah, I mean, we learned a lesson. So now hopefully this doesn't happen in math, and I'll try my best to make some time to at least do some problems and not fall off like completely. Because right now it's December 27th. I already had like quite a few 10 hours, 5 hour grinds, and I'm still this much behind from last year. And platinum is looking pretty slim right now. But we'll get there. We'll get there eventually this season. Thanks for watching. See you tomorrow.